Let's look at the connection constraint in S domain. For both the KCL and KVL, they will hold in S domain for sure, because in time domain you have IT, these add up to 0, right? All the currents. And if you take a Laplace transform based on linearity property, and of course the sum of I sub s, IS should be equal to 0. Let's see if these are the currents leaving or current entering of the sum of the. So any three of these, any one of the three different flavors of the KCL, they do the. If you apply the Laplace transform, they will still hold in the S domain. The same is true for the KVL. So I'm not gonna prove this. Instead, I just use these simple examples to recall the things for the KCL, KVL, right? So there are three different flavors, and the first one is, let's see, the sum of the entering currents equal to 0, right? Or the sum of the leaving currents equal to 0. Or the sum of the entering currents equal the leaving currents. So these are three sort of different convention we're going to use to write the KCL, right? Leaving currents. And in this case, let's see, I have really simple node. We have three currents leaving and entering. That's this node. So let's see if we use the first one here, the entering currents equal to 0. In this case, I would have I1, that's the entering currents, right? I2, that's leaving, but negative I2, that would be leaving. The I2 is leaving, the negative I2 would be entering, right? And I3 is entering, so just add I3 equal to 0. So this is the first, first, second, third. So I'm writing this equation using the first flavor, and second flavor is the leaving currents add up to 0. So in this case, the first current, since it's entering I sub 1, so negative I sub 1 will be leaving. And for I sub 2, that's leaving already. And I sub 3 is entering, so negative I sub 3, that should be leaving. Right? So if we use the third one here is entering currents, here I have I1 and I3. And that should be equal to leaving currents, which is only one current. Here I have I sub 2, right? So this is the three different ways of writing the KCL. And similar for KVL, we can write, we can use the sum of the voltage rises, right? We can use sum of the voltage rises 0, or we can use the sum of voltage drops 0, or we can use sum of the voltage rises equal to the sum of voltage drops. Right, so in this case, let's call this one the first one, the second convention, the third convention, and we can use this this simple three-element mesh to illustrate this, right? So in this case, the first one here, we would have the voltage rises. So let's see, following the right arrow, the clockwise direction for V sub 1 from negative to positive, that's a voltage rise, right? And for V2, from plus to minus, from the left to the right, that's the voltage drop. So we need to put a negative sign since we are counting the voltage rises, negative V2. And for the V3, from minus to the positive, that's the voltage rise, right? So we have V sub 3 equal to, and for the second one here, we have the voltage drops, we are counting the voltage drops. So for the first one here, and the V sub 1, we need to put a negative sign there, and plus the V sub 2, and this is already voltage drop. And for V sub 3, that's voltage rise, so we put a negative sign there. And the third one here, and the voltage rise equal to the voltage drop. voltage rise. So we want 1 and 3. So we have 1 and plus V3. That's equal to the voltage drop, which is V2. Right. So these are 3 different conventions. Make sure you understand that what the voltage rise and voltage drop is if you go from negative to positive, that's the voltage rise, right? Whatever label there. If you want to use the voltage drop from negative to positive, you count the voltage drop, you need to put negative sign in front of that variable there. Okay. And if it's still not clear, go back to lecture 2, and that will we had a detailed explanation with this that identical to what we're talking about here. Okay, so that's all for today's lecture. So make sure you understand this almost as the repetition of the things we talked about in lecture 2. I hope it's not too confusing. And if you have any questions, leave a comment in the comment area, right? And remember, no matter what you do, just keep going, never stop. Okay.